is variable. Someone has entered. Okay, x is variable. Now x can take values, so x lies between a real number, so minus infinity to infinity. Okay, now hyperbolic functions is written in this form: sine h, this h means hyperbolic, and x. So this x is our this variable, cos h x. Okay, x may be complex or maybe real, this way. Okay, now how did it comes into play or comes into existence? Okay, we have e to the power x, that is equal to, you can write it in this way, e to the power x is equal to, you can write it e to the power x plus e to the power minus x divided by 2, one like this function, plus e to the power x minus e to the power minus x by 2. If you calculate it, it will be like this. Okay, now see this function, you look at, if we change x to minus x, what will happen here? It will be minus and it will be plus, so the total thing remains same. So we generate, let us write it as fx, and here it is as gx. So fx is equal to f of minus x. This type of functions is known as even function. But here, if you change it, this does not becomes the same. You have to take one minus sign out. Okay, so here this function gx is equal to minus of g of minus x, right? So if you change the sign of the dependent variable, one minus sign will come here. This type of functions is known as odd function. Odd functions. Okay, so here this even function and this is odd function. So e to the power x is the sum of one even function and odd function. Perhaps you know it. Now this part of e to the power x is known as, we write it as cos hx, cos hyperbolic x. So this is equal to e to the power x plus e to the power minus x by 2, and that part of this function, that part of this sine h x, that is equal to e to the power x minus e to the power minus x divided by 2. Now these two are, x belongs to say R, whole range of R, x belongs to R. Now this is the definition of cos hyperbolic x and sine hyperbolic x. I'll tell you later why these are called hyperbolic. Now see, you just change a, now suppose sine h of minus x. So you put here e to the power minus x minus e to the power x divided by 2. So what will happen? E to the power minus of e to the power x minus e to the power minus x by 2, that is equal to minus sine hx. So this is odd function. You see it? Similarly, you can find it here also. And when you find it, that this is an even function. So sine hyperbolic is an odd function and cos hyperbolic is a, now you can define, so next page. Next page. So you can define sine hyperbolic as tan hyperbolic x. How? It is similarly sine hyperbolic x divided by cos hyperbolic x. You put the value and you will get the result e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x, and x lies between r. Okay. Similarly, you can find cot hyperbolic x from the formula cos hx divided by sin hx, and so on. So all the trigonometric functions can be transformed to hyperbolic functions in terms of these exponential functions. So now one thing is very important to know. What is the, you know that every function have some domain and range. You know it. Functions has some domain, that means fx, where x lies and where fx lies. Okay. So you have to find out if x lies between something here, so fx lies between something here. So sin hx, suppose x belongs to minus infinity to infinity. So what is the expression of sin hx? Sin hx, that is equal to e to the power x minus e to the power minus x by 2. So you put x. First put, that means go on increasing x in the towards infinity. So this function remains always positive and this function remains always negative. So this is a decreasing function and this is an increasing function. Okay. So what will happen to it? Where it will go? So it will go, so you can simplify it, e to the power 2x minus 1 divided by 2 into e to the power x, just like this. Okay, 1 by e to the power x, so e to the power 2x by, now this one, if as x tends to infinity, this will go to infinity. So x tends to infinity, so this one is also tends to infinity. So for x increasing to infinity, the hx also goes to infinity. But for negative infinity, negative value, so this becomes go on decreasing and this go on increasing. So what will happen to it? So it is this function, this is go on decreasing and this is go on also decreasing towards minus infinity. So this function as ax will tend to minus infinity, this function will tend to minus infinity. So the x for x lies between infinity to infinity. This function has range, is very important. Sin h, that is, if I change it now, sin hx lies between minus infinity plus. In this way, you can find out cos hx, domain of cos hx. So for x lies between minus infinity to infinity, cos hx will lie to 0 to infinity. Check it. What is the expression for cos hx? E to the power x plus e to the power minus x by 2. So this is nothing but e to the power x 2x plus 1 divided by 2 into the power x. So for this infinity, for x tends to infinity, this goes to infinity. So this tends to infinity. It is okay. So cos hx lies between. But for negative value, what is the negative value of this? This will go to where? E to the power 2x, it will go to 0. It will go to where? Tell anyone. If x goes to minus
So,
infinity,
so 0, sir.
0. And this one?
So this one also
No.
0.
So e to the power 0 is 1. 1 plus
Yes,
1.
sir.
And this will go to 0 or 1. So
Yes, sir.
this goes to
1
1.
by,
This goes to
yes.
1. Is not it? So here, this will be, this lies between 1 and in. So as this will go to infinity, this will go to 1. Understood? So minus infinity, it goes to 1. Actually, it starts going to, it reaches 1 at x is equal to 0. X is equal to 0. And before, after that, it is always 0. Is that it? So it goes, it reaches 1. And after that, it goes to 0. So this becomes 1 to infinity. That means the negative part of x has been mapped to 1 to infinity, positive part starting from 1 to infinity. So in this way, you have to find out the domain of this function, domain of these functions. Now you can find out tan hyperbolic x, cot hyperbolic x, then sec hyperbolic x, cosec hyperbolic x, all you have to do. So assignment is find the domain of the other functions. Find the domain and range of sec hx, tan hx, cot hx, cosec hx. This is assignment 1. Okay, just do it. Next page. Now I'll give some examples of, say, let us find out the value of sine h x plus y. Okay, so hx plus y, this is nothing but e to the power x plus y minus e to the power minus x plus y divided by 2. Okay, so you can write it in this form: e to the power x into e to the power y minus e to the power minus x into e to the power minus y divided by 2, and that is nothing but half. Oh, you can convert it, you do it. Now, what is the value of e to the power x? So e to the power x, you know, it is nothing but e to the power x is equal to cos hx plus sin h, as in the beginning I have shown. Okay, so you can write it here, e to the power y, and here also you can write it. Okay, so do the and simplify it, you will get the result sin h x cos hy plus cos hx sin hy. Just like sin a plus b, sin a cos b plus cos a sin b. Someone entered. Okay, so this is our, in this way by using this method, you can easily find out what happened. You can easily find out then cos h x plus y and so on. So just put it here and use these expressions and keep e to the power y like this. So I will give you only one. First find out this one and then tan h x plus y. Okay, so this is your assignment to do it at home. I will check it tomorrow. Achha. Okay, next one thing I want to express that this is very easy to do, so you can do it using your primary expressions for e to the power x and e to the power in terms of e to the power x and so on. Now I want to prove one thing, cos h square x. Okay, let me put it in some different form. Cos h square t minus sin h square t equals to 1. I have to prove it. Okay, just what is cot h square t? Now e to the power t plus e to the power minus t by 2 whole square minus e to the power t minus e to the power minus t by 2 whole square. Okay, and you simplify it, you will get it 1. Just simplify. That is very easy to do. Now you see, let t is x is equal to cos hx t and y is equal to sin ht. So what will be this equation? This equation will be x square minus y square equals to 1. What is that equation? It is an hyperbola. Is not it? It is an hyperbola. As you have read in high secondary course, hyperbola. This is an hyperbola. This is an hyperbola with center at anybody? With center at?
Sir, 1 comma minus 1.
No. X square minus y square equals to 1 with center at? Hyperbola. Like this. Center at 0, 0. Understood? Just remember it. This is hyperbola. So if x is equal to cos h t and y is equal to sin h t, so this x and y lies on an hyperbola. So these 2 points, so any point xy is any point that is equal to cos ht sin ht always lies on an hyperbola, is not it? That's why these functions are known as hyperbolic functions. That's why these functions are known as hyperbolic functions. Okay, because any hyperbolic functions, if it is represented by x or y, then it will lie on a hyperbola representing this. Understood? So that's why it is called hyperbolic functions. Okay. Next thing is that you can prove sec h square x minus or plus tan h square x equals to 1. Similar, just sec hx. So you have expressions for sec hx in terms of xy, and you have expressions for tan hx in terms of xy, in terms of e to the power x, and just substitute it here and simplify, you will get the result. Okay, so this is another formula. Next thing is as cosec h square x minus okay, 1 or plus 1 equals to sec h square x. Sorry, not sec, it is cot h square x. Okay, now these are these two formula that can be easily done. Now these are, you have to prove it as assignment 3 and assignment 4 using the technique I have shown it. Now, so just come as behavior of this function. How to judge behavior? You cannot suppose x lies between minus infinity to infinity. Okay. Now, as x changes its values, how these sin hx, cos hx are behaving. Okay, that you have to understood. That is called the behavior of functions, because here we are more interested about not the exact value for functions at any exact point. Understood? But we are interested about how the function behaves if x is changing from through a range on the real axis. Now see, let us take about this sin hx, that is equal to e to the power x minus e to the power minus x by 2. Now you check here, e to the power x, as x goes from less value to the higher increasing value, how this function changes? It goes on increasing, is not it? It is gradually increasing. If you draw the graph, you will see that the function looks like this. Like this. And if you take it at e to the power minus x, how it goes? Now, it goes like this, negative. Okay. So, generally, now see sin hx, e to the power x. So, what is e to the power x? Say at some point here, what is this one is the e to the power x. And what is e to the power minus x? The same point here is. So, value is e to the power x minus e to the power x. So, value of this minus this divided by 2. Is that it? So, how this is the way you can behave. So, how do you do? You have to draw the graph. Draw the graph. That is a very good exercise. So, exercise or assignment for assignment 5. How? Draw the graph y is equal to sin hx. Now take x belongs to say minus 10 to 10. Okay? And use your calculator. Use calculator. Understood? Use calculator and put x is equal to here 10 and find y. So you will get 2 points. Take 2 decimal points. 2 integer after decimal. Okay, suppose some value is say 0.973653561 like you take 0.97 like this. Understood? Take 2 integers after decimal. Understood? Take 2 integer value after it and draw the graph x and y like this. Draw the graph from minus 10 to plus 10. So x should start from minus 10, then minus 9, then minus 8, then minus 7, then 6, so on, and up to class 10. So how many points? 20 points. And you will get a very nice representation of the sin hx graph. Okay, that is your so this 5 you have to do for an initial exercise. You do it and you will see that how this is a continuous curve. You will get a continuous curve just slightly modulated here, and it is gone increasing. So in this side it is gone decreasing, in this side it is gone increasing, and you will get the sin hx curve. But you must remember it, because you are having one thing in your syllabus, that is tracing of the curve, and that will be taught after some time. In that tracing of that curve, you must remember the shape of the hyperbolic functions, e to the power x functions, log x functions, like this. Okay, so this is the behavior. Now you can judge any behavior. So it passes through 0. That is one behavior. Okay, then as it goes away, it increases in this side. It increases very rapidly, and it increases very decreases very rapidly as x increases, as s in the left side as well as in right side. So when x moves towards infinity, it is going very rapidly to the infinite, and as well as the same thing happens in the negative side also. So in this way you have to consider these graphs. Okay, you have to behavior of the graph. Then if you draw the tangent, so I'll show you, if you draw the tangent here, how it will look, or how it behaves, the tangent behaves with the curve. So next day I will derivative of these functions, and then tangent will come out. Okay, tangent can be determined if we understand what the derivative. So these are the functions. Now I want to proceed more, something more here, by inverse circular functions. Inverse functions is like this. There exist inverse functions also. Say sine, sine h inverse x, cos h inverse x, then tan h inverse x. Okay, let y is equal to sine h inverse x. So from the inverse functions we know that x is equal to sine hy, and this is nothing but e to the power y minus e to the power minus y divided by 2. So what will happen? That is equal to e to the power twice y minus 1 divided by 2 into e to the power y. Am I right? Yes. So e to the power twice y minus 1 and minus 2 into x into e to the power y equals to 0. That means e to the power y whole square minus 2 into x into e to the power y minus 1, that's equal to 0. Now this is a square, then so you can easily find out the value of e to the power y here. Can anyone tell? Can anyone tell? Just I am writing it here, x plus root over 1 plus x square, because e to the power y is always greater than 0. So this is a quadratic equation. It will have two roots. One root will be this and another one will be negative. So e to the power y is always positive. So negative root, negative value, we discard it. That means আমরা এটাকে নেব না, আমরা শুধু পজিটিভ ভ্যালুটা নেব. Now this is the Okay, so y is equal to how much? Everybody knows it is nothing but natural logarithm. Natural logarithm, that is y is equal to ln x plus root over 1 plus x square. Okay, now you can draw the graph with x and y, and that will be the curve of y is equal to sin h inverse x. Okay, so similarly you can find out y is equal to cos h inverse x, then what will be the y, and you will find that y will be, in case of this, y will be equal to log x plus root over x square minus 1, just same way. And then in case of y is equal to tan h inverse x, you will find it some other thing. Okay, so you try to find out this one, y tan h inverse x, then y is equal to sec h inverse x. Not tomorrow, you just show me it the in the I will tell you. I will tell you when you will submit your assignment. Now, assignment, you just do it in your copy, then take a image, convert it to a PDF file, and send it from your individual number to me, from your individual number by WhatsApp. My WhatsApp number is 8617805590. Understood this one? Don't send it in this group. Understood? Suppose roll number, say first name, roll number, you are having some name. So A. So from your individual WhatsApp number, you send it to this number. Okay, and I will assign it. You are having 15 marks for assignment, and this assignment today I have given, and this is on the last one. Fourth one is, let me see, third page, fourth page. Where is fourth page? No. This is example 5. Check it. Then this is assignment 2. Okay. Assignment 3, assignment 4, assignment 5. Here, this one is assignment 6. Understood? So these 6 assignments, I will tell you in this group when to submit. Okay? You carry on this one. From individual number WhatsApp to my number, you will send it individually, not all in this group. Understood? Respond me if you
Okay,
understood
sir.
or not.
Yes, sir.
Understood?
Okay, sir.
I will tell you in this number that when to submit it. Okay? I think, shall I proceed it more today? I think that will be, already it is too much for you.
Sir, please show all the slides one by one again one time.
Okay, okay. No problem. This is one, the starting one, slide 1, not slide 1. This is page 1. Okay. You should copy. Whenever I am giving you any much time, you should copy it. Okay. Then number 2. Shall I go to the second page?
Yes, sir.
Okay. Next, from the next day, you just copy. This is page 2. Okay. Page 5. This is page 5. This is page, this is 4th page. Then this is 2nd page, and this is the first page, I think. Yes, this is the first page. This is the 2nd page. Okay. This is the 3rd page. This is the 4th page. And this is the 5th page. And 5th page. And this is the 6th page. Okay. You have to find this one. Okay, this is assignment. Next one is
Sir, this is the last, I think.
yes, this is the last page, I think the 7th page. Then page 6. This is the 6th page. Okay. Assignment 6 is there. Then assignment 5. This is the 5. 3, 4, and 5 is here. Okay. Then assignment 4. This sin s, right? One assignment is there 2. Tan hx plus y and cos hx plus y. Then here this is 3. Find the domain and range of sec hx. This is one exercise. Okay. So this is assignment. Then page 2. Page 2 there is no assignment, and page 1 there is no assignment. So in page 3 the first assignment. Okay. Assignment 1. Understood? Have you got it? Everyone understood it?
Yes, sir.
Okay.
Sir, can you suggest
yes, sir.
us some books?
You can consult any book. The chapter is hyperbolic functions. I am not teaching from a single book. I am teaching from 3 different books. Okay. And it is not possible. But if you follow my lectures and take good notes, then you will get everything. Here, I am just recapitulating. Okay. In
Okay, sir,
page
thank you.
1, in page 1, what I have done, I have just defined the functions. Is not it? I have just defined the functions. In page 1, you see this page 1, I have just defined. So you just remember this one, even and odd function, and then expressions, sin hx and cos hx. Then everything can be, you can easily deduce. Tan hs means sin hx divided by cos hx. So use these expressions and find it. Then cot, then cosec, then sec, everything you know. So next one is, next now number 3, tan hx is there, cot hx. Now how to find this domain and range? How to find this domain? I have done it. Put this plus first and then negative, and then see where the sin hx goes. Similarly for others. Okay. And that will be the domain. And similar, you just use the expressions for sec hx, tan hx, cos hx, like this. Okay. Next 4, here sin hx plus 1. So you know this. So here put an e to the power y, here put u a to the power y, and just simplify, you will get it. All of you have come from higher secondary, so you know how to better than me, how to simplify. Similarly, find this one and this one. This is assignment 2. Okay. Next is number 4. You have to prove this one. How to prove this cos square hx minus sine square hx is equal to 1? I have shown it in the previous one. Yes, here. Okay. So similarly, using these expressions, you can show this. So this is assignment 3 and 4. And here, use calculator. Only one graph I have given. That will take some time to draw it. Understood? And the range is minus x2 plus minus 10 to plus 10. So only 20 points. So 20 times you have to calculate the in your calculator sine hyperbolic x. And I think all of you know how to use the scientific calculator. If you don't know, then this is very unfortunate. You just learned it. Okay. Take 2 integers, and I have taken that only I have taken up to 2 integers. I have not made it 4 integers. Okay. 2 integers only after decimal. So you can draw it. Only one graph I have given. I have not given, but ultimately you have to do all the graphs. Then in 6, inverse functions. Okay. Then I have. So only one assignment is there here to find out this type of expressions or this type of expressions. Understood? And in 7, what happened? I've just did 6 or 7. Both are same, I think. So this is the, but send it individually to me. I will tell you you continue. I will tell you, I will give you 4 to 5 days time to do it. Okay. So just now, I'm just, do you need more? So I'm just hiding this board. Is that okay?
Okay, sir.
Okay, sir.
Okay. Then today there is more, another 13 minutes time is there. So I want to discuss something about your syllabus. Do you have syllabus with you?
No, sir. Sir,
don't
we
have
not
syllabus?
good,
No,
sir.
sir.
Okay, you need syllabus. Is that it? So I am just searching the syllabus on my board. Where it is? You don't have the syllabus, no? That is a great point. Okay.
স্যার মনে হচ্ছে স্যার পুরানোটা আছে স্যার, নতুনটা যে কমানো হয়েছে স্যার ওটা নেই।
না, তোমাদের এটা ভুল ধারণা যে তোমাদের কমানো হয়েছে। এইবার এই নতুন তোমাদের ফার্স্ট সেমিস্টারের জন্য কমানোর কোনো নোটিশ আসেনি। সবার আগে এটা বুঝে নাও, কমানোর কোনো নোটিশ ফার্স্ট সেমিস্টারের জন্য আসেনি। সেটা এসছে থার্ড সেমিস্টারের আর সেকেন্ড সেমিস্টারের আর ফোর্থ সেমিস্টারের। তোমাদের জন্য কোনো নোটিশ আসেনি। সুতরাং আমরা যেটা বুঝতে পেরেছি সেটা হচ্ছে আমরা ফুল সিলেবাসটাকে ধরে নিয়েই আমরা শুরু করব। তারপরে যদি আসে তখন আমরা সিলেবাসটা কাটেল করব। কথাটা বুঝতে পেরেছো? Have you
আচ্ছা
understood
স্যার।
this? There is no notice till date to curtail the syllabus for the first semester. Okay? So we are not going to cut it. First in the syllabus unit 1, this hyperbolic functions is there, and next is there higher order differentiation. So I will take 2 or 3 class for hyperbolic functions, and then I will switch over to higher order derivatives. Okay, after higher order derivatives, then I'll tell you another 2 chapters. Understood? And these are mostly of geometry. So you should know what is tangent, what is normal, then how it can be calculated using the derivatives. So next day I will start from derivatives of the hyperbolic functions. Okay, and today I am bit slow. I like to be uh, bit faster. Okay. So by 3 class, I will usually I end it in this hyperbolic functions by 3 or 2 classes, and in past course classes only 1.5 classes. Okay. So today I just want to end it here today, as this is the first class on hyperbolic class. Okay. Thank you very much for attending. And tomorrow I shall take class at the same time, and I will I will post the link today. Just see your group WhatsApp. Okay. Thank you. Thank you very much. Okay.